Welcome to the deep dive. Modern industries, they're just getting incredibly complex, right? And the amount of data flying around is, well, it's staggering, just mind-boggling. We're talking petabytes streaming in daily sensor data, logistics, customer feedback, you name it. So today, we're diving headfirst into this, our topic. Big data analytics and industrial engineering. Our mission here is really to cut through all that noise. We want to get a handle on how this big data analytics stuff is fundamentally changing how companies work, how they make decisions. We'll unpack the crucial role it plays, the opportunities, which are pretty exciting, and also, let's be real, the challenges involved in actually making it work.
Exactly. And big data analytics, at its core, it's really about systematically using computational power to analyze these massive, massive data sets. The goal, to uncover patterns, trends, insights that, frankly, were just invisible before. It's a huge shift. We're moving away from, traditional engineering that often relied on experience, maybe intuition, towards strategies really driven by data, thanks to statistical analysis, machine learning, predictive models. And the data itself is diverse structured numbers from databases, sure, but also unstructured stuff like text, images, even video, all capturing different aspects.
Okay, so let's talk about that shift. Because historically, yeah, industrial engineering leaned heavily on empirical methods, maybe gut feeling sometimes. This feels right, or we've always done it this way. Herb, so for an industrial engineer today, what does adopting these data science techniques actually mean day to day? What's the big change?
Well, the fundamental change, the real game changer, is moving towards a much more informed and crucially proactive approach. We can now do things like forecast maintenance needs with surprising accuracy, optimize entire supply chains dynamically, and really boost product quality before defects even occur. It's not just about predicting if something breaks, but finding that optimal time for maintenance, balancing cost, uptime. It gets complex.
Yeah.
So this isn't just a trend, It's a necessary evolution. It changes how teams work, shifting focus from just fixing problems to strategically preventing them.
That proactive element sounds key. So where is this data making the biggest waves right now? What specific areas in industrial engineering are seeing the most impact from big data analytics?
Right. There are several really critical applications. First off, supply chain optimization. Here, real-time data lets engineers not just forecast demand, but actually predict subtle shifts. This allows for much smarter inventory management, less holding cost, happier customers because things arrive on time. It helps find those hidden bottlenecks, too, for quicker fixes and better resource use.
Okay, smarter supply chains. Makes sense. What else?
Then there's predictive maintenance. This is a big one. It's about using sensor data, historical performance, feeding it all into machine learning algorithms. These algorithms can then predict equipment failures before they happen, so you minimize unexpected downtime, extend the life of your machines, and cut maintenance costs by doing it exactly when needed, not just based on a schedule.
Avoiding those costly breakdowns. Yeah, I can see the value there.
Definitely. And in quality control, big data offers insights we just didn't have before. Imagine analyzing every single parameter in production: temperature, vibration, pressure, everything. This lets engineers pinpoint the exact root causes of tiny defects or variations. You can take corrective action much faster. The result: better product quality, less waste, and importantly, more customer trust.
Interesting. So finding those needles in the data haystack to improve quality?
Precisely. And finally, production planning. It's been transformed. Analyzing comprehensive data allows for way more effective resource allocation, balancing workloads, sequencing tasks, basically optimizing throughput. And the real-time aspect is crucial here, too. Plans can adapt dynamically on the fly to sudden demand changes, material shortages, or machine issues. Keeps the whole operation much more agile.
Okay, this is where it gets really interesting. These aren't just theories. The opportunities are translating into real, measurable improvements. Can you give some concrete examples? Who's doing this well?
Absolutely. Let's talk examples. For enhanced productivity, Siemens is a standout. They're using operational data from their factories, machine logs, sensor readings to create, essentially, digital twins of their production lines. This lets them simulate, optimize processes, predict maintenance needs, leading to major gains in throughput and less downtime. We're talking significant percentage increases in output.
Wow, digital twins for productivity.
Yeah.
Okay, what about cost cutting?
For cost reductions, think Walmart. They go beyond just tracking sales. They use big data, incorporating things like weather forecasts, local events, even social media buzz to fine-tune inventory. This incredibly granular insight means they slashed storage costs and cut down on waste because they know much more precisely what to stock, where, and exactly when.
That's smart, using external data too, and customer insights.
Procter & Gamble, P&G, is a great example for enhanced customer insights. They use big data not just for sales tracking, but to really understand subtle customer preferences and how products are used across different regions and demographics. This allows them to create super targeted marketing campaigns and even tweak product features. Builds much stronger customer loyalty.
So tailoring things right down to the individual level, almost.
Getting closer, yeah. And for improved product quality, General Electric, GE, uses analytics extensively in their manufacturing. They integrate real-time sensor data from every production stage with historical quality data. This means they can spot anomalies instantly, make immediate adjustments on the line, and maintain incredibly high production standards. Fewer defects, fewer recalls.
Instant adjustments, that's powerful. And finally, speed.
Speedier decision-making, yeah.
Yeah.
Companies like Tesla are really leading the charge here. They use analytics not just for market analysis and consumer demand, but to rapidly iterate on vehicle design and manufacturing itself. This data-driven agility lets them pivot strategy quickly and stay ahead in a really fast-moving market.
Those are some powerful examples, really showing the breadth of impact. But like we said, it's not all smooth sailing.
Yeah.
Implementing this kind of change, it must come with challenges. What are the main hurdles organizations hit?
That's a critical point, and often underestimated. A huge one is simply data quality and integrity. You're pulling data from everywhere, sensors might drift, timestamps could be missing, formats from old machines might be inconsistent. Ensuring that data is accurate, consistent, reliable, it's complex. And bad data, well, it leads to bad insights. Garbage in, garbage out, as they say. It can lead to some really poor decisions.
Right. The data has to be trustworthy to begin with. What else?
Skill gaps. This is major. Industrial engineers and their teams need advanced analytical skills. Many just weren't trained in data science. So companies need to invest heavily in training, maybe hire new talent, or even create roles like data translators who can bridge the gap between the data folks and the operations folks.
That makes sense, bridging that knowledge gap.
Exactly. Then there's integration of diverse data sources. Think about it: real-time streams from machines, batch data from logistics, maybe text from customer feedback. Getting all that OT and IT data talking to each other in one unified system, that takes serious technical effort and smart management.
Yeah, combining apples and oranges data-wise.
Sort of, yeah. And data privacy and security are huge concerns. You have regulations like GDPR, plus understandable fears about data breaches, especially with sensitive manufacturing secrets or IP. This can make companies hesitant, especially about cloud solutions or sharing data.
Understandable hesitation there.
Definitely. And finally, maybe the toughest one, changing organizational culture. You need a shift towards a data-driven mindset at all levels. That often meets resistance. People might worry about new tech, fear for their jobs, or just lack basic data literacy. It's not just about the tech, it's about changing how people think and work.
The human element. Always crucial and often the trickiest. So, despite these hurdles, this is clearly happening. What technologies are actually making it possible? What's the engine behind this big data boom in industry?
It's really a convergence of several key technologies working together. Cloud computing is fundamental. It offers scalable storage and processing power without massive upfront investment in servers. This makes real-time analysis feasible, even for companies dealing with enormous data volumes, especially during production peaks.
So the cloud makes it accessible.
Very much so. Then you have machine learning, ML algorithms. These are the brains, really. They're incredibly good at finding complex patterns, predicting failures, optimizing processes. Things like decision trees for finding defects, or reinforcement learning for optimizing robots or factory flow. And they get better over time as they learn from more data. They're indispensable now.
Learning on the job, essentially.
Pretty much. And the Internet of Things, IoT, provides the senses. Connecting physical machines and devices with smart sensors creates this vast network gathering real-time data on everything: vibration, temperature, energy use. This gives you that incredibly detailed real-time view needed for things like proactive maintenance. Though managing that fire hose of data is its own challenge, of course.
Right. The data flood from IoT.
And finally, don't forget advanced statistical tools. They're crucial for analyzing and visualizing complex data, helping engineers spot anomalies, understand trends, and importantly, figure out why things are happening, not just what. That causal inference piece is key for real improvement.
Okay, so the tech stack is powerful, but seeing it work in the real world is always more compelling. Do we have some case studies that show this transformation in action across different industries?
We certainly do. These really drive the point home. In manufacturing, think about an automotive maker. They used analytics not just to optimize the line, but to get incredibly close to zero defects. By analyzing data from every robot, every sensor, every quality check in real time, their predictive models caught potential flaws before they became actual defects. Huge impact on downtime, output, and costs like rework and scrap.
Near zero defects. That's impressive. What about logistics?
In logistics, picture a global shipping company. They totally revamped their supply chain using big data, analyzing routes, shipment tracking, weather, even geopolitical events. They used machine learning to predict demand changes incredibly accurately. This meant they could reroute shipments dynamically, position inventory smartly, and achieve significant cuts in delivery times and fuel costs. Better service, leaner operation.
Wow, predicting global events to optimize shipping. That's next level.
It really is. And in the energy sector, a major utility company used analytics to manage its entire electricity grid. By analyzing smart meter data, forecasting consumption, identifying patterns, they could allocate resources better, predict infrastructure maintenance needs, and respond much faster to demand spikes or supply issues. Even with tough challenges around data security and integrating old systems, the payoff was huge. Cost savings, better distribution efficiency, and a more resilient grid.
Fantastic examples. They really show the breadth of application. So looking ahead now, what's next? What does the future hold for big data analytics and industrial engineering? What trends should we be watching?
Well, the reliance on data is only going to grow. We'll definitely see an increasing reliance on real-time analytics. It's becoming absolutely essential for efficiency and quick decisions. Think about those digital twins expanding to model entire factory ecosystems in real time.
Real time becoming the standard, basically.
Pretty much. And linked to that is the rise of autonomous systems, systems powered by advanced ML algorithms that can self-optimize factory lines, automate quality checks, make decisions with less human input. That's going to revolutionize things, driving new levels of autonomy.
More automation driven by data.
Exactly. And the integration of artificial intelligence, AI, will go deeper. As AI gets more sophisticated, it'll boost data processing, improve analytical precision, leading to even smarter engineering solutions, especially in robotics, and maybe even generative design for products.
AI taking another step further.
And finally, evolving data governance will become even more critical. More data, tighter regulations. It means you need really robust frameworks for data integrity, privacy, compliance, clear roles for data ownership, maybe more sophisticated ways to manage distributed data, like data mesh concepts.
Governance keeping pace with the tech, that's crucial. Okay, this has been incredibly insightful. For our listeners out there, maybe industrial engineers or managers thinking about this, what are the key best practices? How can they effectively leverage big data analytics in their own work?
Great question. To really make it work, first, you absolutely need proper data governance frameworks. Define clear roles, responsibilities, standards for data. Who owns what data? What are the quality standards? Think about appointing data stewards. This builds trust, ensures reliability, makes sure everyone's on the same page about what the data means and where it came from.
Laying that solid foundation.
Okay. Second, cross-functional collaboration is non-negotiable. Industrial engineers can't do this in a silo. They need to work hand in glove with data scientists, IT folks, business managers, even the operators on the floor. This breaks down barriers, shares knowledge, and ensures the solutions actually solve real operational problems effectively.
Teamwork makes the dream work, data style.
You got it. Third, investing in training and development. You've got to equip your people. Offer continuous learning workshops, courses, projects. Help them become data literate so they can understand the insights and ask smarter questions of the data.
Upskilling the workforce. Essential.
Absolutely essential. And finally, robust data security measures. This has to be paramount. Advanced security protocols, encryption, strict access controls, regular audits are needed to protect that sensitive operational data. Maybe even adopt a zero-trust approach, where every access request gets verified. You need a secure environment for analytics to thrive.
Wow, okay. What a deep dive this has been. It's absolutely clear that big data analytics offers massive opportunities in industrial engineering, efficiency, quality, innovation. It's all there. But as you've highlighted, it also brings real challenges, particularly around data quality, skills, and maybe most importantly, that organizational culture piece. Leveraging this data effectively isn't just an option anymore, is it? It feels like a necessity in today's world.
It truly is becoming table stakes. And to really capture those benefits, the final thought I'd leave you with is this. As industrial engineering professionals, you need to be the champions for this. Actively advocate for and help build a data-driven culture in your organizations. That means pushing for data literacy, making the case for strategic investment in the tools and the training. Because ultimately, this commitment isn't just about making things run a bit better. It's about leading transformative change and driving real sustainable growth for the future of the industry.